the question is, what are the Pyomo elements and what exactly Pyomo is doing for us? So to answer this question, you should know that it's you who writes down the problem description. So you have to mathematically model your problem. Suppose you are about to solve the diet problem, and you want to have some specific amount of proteins, carbohydrates, and also, for example, fats in your diet, okay? And you need to be able to choose how much, for example, rice I should take, how much meat I should take, how much bread I should eat every day, okay? So this is the typical diet optimization problem, in a way that not only I'm paying the minimum amount of money, but also I supply them the required amount of vitamins, proteins, and different things to my body. So you have to somehow mathematically formulate your problem. So Pyomo doesn't understand the physical nature of that problem. You know, it doesn't really understand what is the physics or what is the diet or what is whatever. So it only understands the mathematics. So you have to mathematically formulate your problem and then pass it to the solver. So I should say that Pyomo is not solving your problem. These are the solvers who solve your problem. This means that Pyomo is only acting as a translator, so it will translate your problems for the developed solver, which is at the back of the problem. So for this reason, we have to know what are the components of each Pyomo code. So first of all, the model. The model is the most important thing in Pyomo. You have to create your model. You have to build your model based on the actual problem you are trying to solve. Okay, so the models can take different forms: abstract form, concrete form. Abstract form is a more general way of representing the problem. So it means that for a set of variables or set of elements, these are the relation that should be valid. But concrete ones are numerical values inside the constraint. So every Pyomo code can have different elements. For example, the sets, variable, parameters, constraints, and objective. So the set can take different values, for example, and also solving that and visualizing that, okay? And this part that I have specified construct the Pyomo elements, okay? And then we can visualize that. So let me give you some examples regarding the sets. For example, the set can be defined as the range set starting from 1 to model.n, or it can be defined as an empty set like this, and then using some data file, you can feed the required data into the set. Or the next one is the variables. For example, the way you define your variables is this. Some variables are defined over the sets, some of them are not defined over the sets. They might have some bounds. It means that the variable is changing between these two limits, the minimum value and maximum value. You can initialize them, and they have some domain. It means that what is the type of the variable you are dealing with. It can be real, it can be binary, or if it's real, it can be positive real, percent fraction, it can be something real between 0 and 1, negative real, unit interval, the same as 0 to 1, or non-negative reals, or it can be binary, boolean, positive integer, non-positive integer, negative integer, and non-negative integer. Okay, these are the different types of the variables that you can have in a Pyomo code. Or the parameter, these are the constant numbers that are before solving the problem, we know their values. Okay. Or the constraint. The constraints are very important. These are the equations describing the relation between the variables, sets, and also the parameters. For example, you have to define, you need to choose a name for each constraint. So model.0 is equal to constraint. That constraint, that specific one, is defined over model I, which is a set, and a rule. So you have to separately define the rule. That specific rule is named 0 rule. So that zero rule is defined over I, the same as here. So if you have I, you have to have I here, and returns the summation of the model.u ij for j in model j less than equal to 1. So that does the summation over j, and the remaining set is I, which is here. Okay, and finally the objective function. The objective function has the same kind of role as the constraint, but in this way we want to optimize it in two senses. It can be minimized, it can be maximized. Okay, and so for the solve statement, this is very important. As I already explained, the solve statement is asking Pyomo to solve the model. So if it's a concrete model, you have to choose a solver and ask the Pyomo to solve the model. But if it's an abstract model, after choosing the right solver, you have to create an instance. It means that that snapshot of the model with that given input data. So you can define a dat file and put those input parameters inside that file, and then ask the Pyomo to solve it for you using the chosen solver. Okay, and here you know that after that it's the final version. The final step is the visualization. Okay, it's very important to somehow communicate the results of your decision making process for the audience. Thank you very much.